All right, so for experiment 6 is the determination of tartrazine in beverages. So what you would have started with is tartrazine stock. So the concentration of my solution is different than the one that you had in lab, but the calculations will be the same. So if I had 50 mils of stock, again, the volumes may be different from what you see in your own experiment. You just have to adjust accordingly. So if I took 50 mils of stock, which is 0.375 millimolar, and I diluted it to a total volume of 100 mil. To figure out the concentration, we use M1V1 equals M2V2. So my M1 is the stock, which is 0.375 millimolar, times 50 mils, and then that will be equal to M2, which is what we're determining, times 100 mils, which is the total volume that you diluted it to. So that ends up being 0.188 millimolar. And then for the second solution, again, you should have done the same type of dilution. You took 50 mils out of solution 2, diluted it to a total volume of whatever that might be. So this concentration here just gets put down here. And my new concentration is 0.094. And then you just keep doing that again. So this is 0.094. And M4 equals 4.7, etc. So, and then M5, 0.0235 millimolar. Okay, so the calculations are the same. You just keep moving the one solution to the next one. And hopefully when you do your calculations, your solutions go from very large to smaller, and there's not other things in between. And again, hopefully your colors will correspond to the concentration there. Okay, so once you have done that, you have your different blanks, and then you have your absorbances. I just put the concentrations next to here so you can see what they were. These would then go into your spreadsheet, and then you would spit out a graph. So the graph looks like this for my data, and it has a line. So this is a fairly straight line, so dilutions were performed pretty well. The only thing, and then you have this slope here. So y equals mx plus b. So make sure that your graph has concentration in millimolars on the x-axis, and on the y-axis is absorbance. That will give you the right slope. To determine the concentration of your unknowns, you took two measurements of two different unknowns. For this is the Greek value, whatever this was called, was 0.470, and for Mountain Dew is 0.776. So you can use this line to determine what that is. So my y equals the mx plus b, the m being 3.6165, and then x, and then 0.0129. So to solve for x, you just have to put in the absorbance that you obtained from your measurement, and that will be plugged in for y, because that was on the y-axis. So y equals mx plus b, and this ends up equaling 0.126 millimolar. And then you can do the same thing for the Mountain Dew. And so again, to solve for x here, you would subtract this to the other side and then divide this value by 3.6165 to get this.